Hey everybody, welcome back to Weekly CTI, another great episode coming at you today. We're going to take a look at the GoBruteforcer Botnet Malware. It's going to be very enlightening and a lot of fun to boot because we're going to learn about that so that we can learn from it, be better cybersecurity professionals. That's what it's all about. Yeah, and I'm wearing my Batman shirt today, so how bad could life be, right? If you got Batman shirt on, nothing to touch you. Know how it works? If you can be anybody, be Batman. Well, today I'm Batman. That's what I'm going to do. That's what I'm liking. Hopefully you're Batman as well. Before we get too far down the road, find it, like, subscribe, notification bell, leave me a comment. Don't forget to share with your friends if you like what you're seeing. Also, there's a buy me a coffee link down there. If you like what's going on in this here weekly little segment we like to do, throw me a bone or two. That'd be nice, and we can use that to invest back into the channel, get some cool stuff, and do the cool stuff. So that's what it's all about. And all right, let's get to it. Let's get cracking. So today is about the GoBruteforcer botnets targeting web servers. It is targeting web servers. Okay, yeah, but it's okay. So it's targeting web servers that have certain services available. We'll get to this a little bit. Let's take a look. This is from SecurityWeek and our intrepid reporter back there. Again, I dare not attempt your name, and not out of disrespect, but just because I do not feel competent enough with wherever you're from to, attempt it. So we can read. There we go. We'll let you read the name. Okay. It says a recently identified Golang botnet or Golang-based botnet. Ooh, it's in Golang. And is that why they call it GoBruteforcer? Because for whatever reason, I'm thinking of the kid with the oh man, it was a Speed Racer. Yeah. Thinking go Speed Racer, go, right? Go Bruteforcer, go. Now, if they put some ASCII art of that kid with his helmet on and the little car and everything, that would have been kind of funny. A little calling card, but they didn't. It seems to be targeting web servers running FTP, MySQL, phpMyAdmin, Postgres services, the PaloAlto network's support. And of course, it is dubbed GoBruteforcer because it is written in Go, and it is brute forcing things. You put those things together, you got yourself a brand new malware botnet word. It's a fun world we live in. I like to say that, that word sounds made up. But then you remember, aren't all words made up? I think they are. So that's fun. So you can't get somebody with that one, right? You can't say, that's a made up word. All words are made up, right? So don't jump on someone for doing that. All right, again, you can jump to the article if you like. We're going to hit the details. That's what we like. This is the highlights here in the article, but it's a great article and does give you all the things that you need. I always read the SecurityWeek or the Hacker News or wherever I'm at. I always read that article first to see how much I can glean from that. This was a really good article. You will get a lot out of it. But if you're like me and you like to dive into the details a little bit because you want to learn about those things in greater depth. And I did learn about a few things, specific things, right? That's kind of what it's all about. The devil's in the details. Find out about those details so I can expand my knowledge, and hopefully you can expand your knowledge as well on security, right? Okay, what are bad guys doing? What are, what kind of tools are they using? What kind of techniques are they engaged in? What are their procedures for making things happen? Is there a new threat group? Is there a new malware? How can I defend against it? What do the IOCs look like? Those are the little, right? The little pieces of goodness that are also bad that I really look forward to and I can learn from. And hopefully you also learn from that. So let's jump into, this comes from Unit 42 at PaloAlto Networks. If Unit 42 sounds a little bit like Unit 8200, I could be wrong. Don't quote me, but I'm fairly certain that the folks at PaloAlto Networks are people that were in Unit 8200 and now they have Unit 42. I could be mistaken, but I think that's how this goes. So, super smart cybersecurity samurais, right? That's what we're hoping to be. So, just that proximity principle, right? You get around somebody and you kind of pick up from them. I'm a musician, as you might be able to tell. I got guitars and things behind me. And I always realized that the more I was around people that were better than me, the better I got. Welcome to Weekly CTI. That's what we're trying to do. Learn from people that have skills above us, that are doing things at the level that we wish to achieve. And that should bring us up to speed. All right. Let's learn a thing or two about GoBruteforcer, as we kind of already got there, and here the executive summary is very detailed, honestly. Goes into the meat and potatoes of what GoBruteforcer is about. I got my notes over here ready to kind of give you the quick and dirty, and then we'll dive into those details. So it's a botnet malware, right? We love botnets. They are our favorite thing in the world. I'm being facetious. Written in Golang, as we discovered, they're targeting web servers that are running FTP, phpMySQL, Postgres, phpMyAdmin, MySQL, and Postgres services. So if you got that rocking, that is what's up. They discovered this using their next-gen firewall, and that's kind of cool. And it does attack after x86, x64, and ARM processors. So, and whatever architecture you're on, probably this malware will work in some way, shape, or form. All right. So let's see here. Well, like I said, it was discovered by Unit 42. They also discovered that it uses the UPX. Now, you might not be familiar with UPX. Let's do a little Googling. UPX packer. This is a packer, and it's apparently a fairly common packer. And you got UPX, the ultimate packer for executables, and this is the GitHub page for it, or at least it looked like it. Oh yeah, the upx.github.io tells you a little bit about this. And what packers do is they use compression to basically shrink down the amount of code, or the size of the code. And maybe that's a better way of putting it. It shrinks down the size of the code by, compressing unnecessary things. So it goes, oh, I don't need this to know what that is, kind of breaks things down into smaller. I think that's what I'm getting here, right? An advanced executable file compressor, UPX typically reduced the file size of programs and DLLs by around 50 to 70%. Thus reducing disk space, network load times, download times, and other distribution and storage costs. Absolutely. So the packers are a really cool thing. Here's what's up. So if you're running Linux, you probably have it installed. Well, guess what? I'm running Linux. Let's do this. Let's go to a different desktop. Let's open a terminal here. There it is. Let me make the font in a human readable size. Where's this? Here we go. So if I do UPX, you'll notice I have UPX installed. Of course, if you don't, apt-get, yum install, whatever you got, pacman, and get this thing installed. And you'll notice it has some commands. It's fairly simple and straightforward, right? Compress faster if you need to decompress, if you need to test the compressed file, if you want to compress better, list the compressed file, display the version number, so on and so forth. Be quiet, so don't do a lot of output, or maybe any. And then here's basically how you take any of your options there, you chuck it through the meat grinder, tell it what your output file is, and then give it your input file. So it's -o output file, and then the last thing you do is tell it the file you want to compress. Pre-gamed a little bit for this, and I've got netcat right here, right? And if I do an ls-alh on and C, we can see that it is a 35K file. We can also do strings, and C, I'll pipe that to less. And I can read strings that are in there, right? So giving me some information about what architecture it was compiled for. I see things like socket and string copy and fflush. We've got an exit statement there, connect. It's just a simple and easy way to kind of like look and see if you're doing any kind of reverse engineering, especially of things like malware. This is a standard procedure for trying to understand what is going on inside the malware. What's under the hood? Let's pop the hood on this baby and see what kind of horsepower she's running. You got a 4-barrel carburetor on that there, son. You got to tweak that up, give it a little more on the jets. Yeah, yes, I know a little bit about cars. Let's see here. So yeah, I can look through here and start really trying to learn more about it. Maybe something that glibc stuff and libc. Maybe it gives up the ghost on something to do with the malware. Of course, there's ways to decompile using things like Ghidra or IdaPro or something, but strings is a quick and dirty way for us to kind of get into deconstructing a malware. I'll quit out of that. So what I'm going to do is I'm going to use UPX, right? UPX, do -o, and I'm going to call it nc_packed. And then we'll feed it nc, hit enter. Looks like everything went well. Looks like we compressed by around 44.36%. If I do an ls-alh nc star, I can see that, yep, right around about half of the size of the original NC. And if we do strings NC packed, and pipe that to less, you'll notice that, well, I do see UPX. Well, I know this is packed now. Oh, there's UPX on this, so this has been packed. I'm not seeing everything. Things are kind of truncated or like maneuvered. It's not as easily seen. I do see fflush. I do see copy, which probably was string copy, but it's because it's compressing that things down. Now, the cool thing is like for us as humans, yeah, we kind of look at that and go, huh, that's probably string copy. That's probably this, probably that. But if you're writing malware, you got to remember signatures, behaviors, certain strings even can be identifiers to antivirus, EDR. So how do we get around that? Well, run it through a packer. Packer is a very common way in which malware is obfuscated in a way. Plus, it makes it smaller, makes it easier to kind of use if it's smaller footprint, not such big file running around. Like we're always trying to make our files smaller, make them easier to transmit, smaller footprint on the system, especially botnet malware, right? Because if you're on a botnet, you're probably going after IoT devices and things of that nature. So UPX packer was used, and now you can kind of get a little bit of an idea of why and how that works. I figured that would just be useful for us. All right. So now that we know that, what else do we know about this lovely little GoBruteforcer thing? Let's see, it utilizes that. It does a CIDR block scanning, and it's funny, on my notes, I forgot to highlight that. I'm just going to fix that now. Bam. CIDR block scanning. So instead of just basically giving a list of IPs and saying, hey, scan these IPs individually and see if they've got any of the stuff you're looking for, like FTP, MySQL, phpMyAdmin, so on and so forth, it takes CIDR blocks, runs them into the meat grinder, and then says, hey, let's see if I can, and then just starts scanning. Hey, you alive? Hey, you alive? Hey, you alive? Oh, you are alive. Well, hey, how's it going? How you doing? Come here often? You don't happen to be running, just asking for a friend, just out of curiosity, purely scientific research. You wouldn't happen to have port 80 or, maybe, I don't know, 3306 open, maybe 5432. Just, like I said, no real reason, but if you do, you let me know that. That'd be great. So that ends up what's going on. So once it finds an IP in those CIDR blocks, then it will pull it. It will say, okay, I've got this as a list. I can then move to the next stage of my operation, which is the multi-scan module. Okay. So the multi-scan module is a really cool part of this. Let's see here. I think we should be probably getting into this probably about now. The introduction, CIDR block, and here's kind of how this works, right? So it scans for ports 81, 21. Oh, that's right, because FTP 3306 and 5432. Are they open in the network? Bing, if so, try to brute force that. And then if you make contact with this in some way, shape, or form, either through phpMyAdmin, so it's kind of got conditional logic. If it's through phpMyAdmin or one of the other services, it's going to take one of two routes. It's either going to drop an IRC bot or it's going to use a WebShell for C2 comms. And there you go. We got comms with the very funny looking attacker. It is kind of funny. It looks like he's got a big glass of, whatever in front of him. See, I guess that's supposed to be a shirt. And then it'll drop this cache init file. But yeah. Oh, I forgot about the hard-coded creds. There are hard-coded creds in I think the phpMyAdmin module. So there's a bunch of modules. We'll get to that. But I'll use these hard-coded creds for the brute forcing of these things. And maybe it works in both. I can't remember right now. We'll get to that. All right. And then last but not least, it gets into, we talked about what happens after it compromises, whether it takes one path or the other. And then this right here, this is money stuff. So it makes this folder or directory called .x, which in a Linux, obviously this is targeting Linux, Unix type systems, okay, or Nix-like systems. So it makes a .x folder or directory, which is hidden by a standard ls, right? So if I do an ls, right, let's ls, we see these things. If I do ls, or if I do, if it's alias, I'll just do an ls-l. I guess I got to do a -al, Daniel, ls-al. You see all these things with dot stuff in front of it. Those are hidden. You notice they did not show up in even the long listed format, right? We have all this stuff like .bash history. It's a hidden file. You don't need to see it all the time. But people tend to forget about it. So it makes this, especially if you're not expecting to think there is something hidden there, it's a very good way to hide in the fact that you're not expecting it to be there. So you just hide the folder .x. All right, then it makes a 64, 32, or ARM folder, depending on your architecture. And it makes this lovely little, where's it at? There it is, cache init file, right? This is the GoBruteforcer malware itself. This is the binary for that. So if you want to stop right now and you got a Linux server that's touching the internet, you're running one of those or many of those services, take a minute, pause the button, and then head over to the server, do an ls-al, and look for a .x folder in your root directory of your web server. All right, so there you go. Yep, targeting Nix platforms. And we believe that GoBruteforcer is in active development, and as such, things like initial infection vectors or payloads could change in the near future. So still in kind of a developmental phase, it would seem. Then we get into our favorite scanning and system access. I'm sorry, Dave. We've taken over. All right. Let's see here. Good old Hal. GoBruteforcer malware samples are packed with UPX Pactor, which we did see. They gave us a lovely SHA-256 of the sample that they discovered. And then here they are talking about how, okay, so this is where, right, this is us doing scanning and system access. So we're going to start with scanning. First, the malware gets released. It starts to scan. It's looking, right? It's using that CIDR block. And I think it's pulling like a random block of IPs from a random CIDR. And yeah, there it is right here. You can see xmisc random CIDR in this box right around here, right? So we're looking at the what looks like assembly code. So this was apparently decompiled. This is then reverse engineered by Unit 42, showing us what steps the code is making in the assembly, because we can see call, moves, and jumps. And here are registers and all sorts of fun stuff. But here's the call to X. This is a variable x_misc_ random CIDR. So cool. Give me a random CIDR block, and then we can start good old scanning. And then you can see as it kind of jumps down in here, right, move call. Then it does this call to x_misc_ get hosts. So what are the hosts that we have discovered in this? Once it has those, it says on the target IP address, the malware starts scanning for phpMyAdmin, MySQL, FTP, Postgres, right? So these are all service scanners that they have created that are built in here, and there's a service scanner for each one of the different services that they wish to scan for. So we've got X scanners, phpMyAdmin check, right? Then there's another one down here, X scanners, FTP check. We got another one, X scanners, Postgres check, so on and so forth, and on we go. Inside these modules, the malware first checks for the port belonging. So not only does it check for the service, it's checking for the port first to see if it's open, and then the port scan module here inside. So it's saying, hey, oh, this is inside of each one of those scanners. So they have a. That's right. I'm getting things backwards. Okay, let me bring this back. Focus, Daniel. You've got this. So you've got the scanner modules. Inside of the scanner modules, so like the X scanner phpMyAdmin module, there is a port scanner module that is in that module itself. And that port scanner module is within every one of these scanner modules. So I don't know why they reinvented the wheel like that. I didn't develop this, so it seems a bit redundant. Maybe I don't know why they couldn't just call out to a scanner like recursively, but hey, interesting. It is a part of each one. And you can see here it is called xmisc. So the letter X as in X-ray, misc as in miscellaneous, and then port open. So underscores between all that and some camel casing going on. So it's checking for those ports. Are they actually open, right? Once it does figure that out, or I guess what the next phase is to kind of figure out whether or not, if that port is open, is that the service? Because that's what it does for the phpMyAdmin, right? Actually, this is where it brute forces. It starts brute forcing. Okay, you got the port. The right port is open. It's running, and we're good to go. It says the Bruteforcer the GoBruteforcer malware tries to log in and get access to the victim server via a brute force. And here are the hard-coded credentials, a little picture of that they discovered that is built in. And you can see all these different passwords. None of them seem like amazing. Some of them seem pretty mundane, honestly. Like we have error root as a password, 1234567 root, A123456 root, app test root, Asus Tor root, backups root, Bitcoin root, Charlie root, freedom root, let me in root, Michael root. I don't know why that would be in there, but yeah, I guess it is. Pass 123 root, root 123 root, test 123 root, Tor 123 root, tour, I guess, tour, which is root backwards. There's Tor 321 roots, welcome root, Windows runtime. So none of these passwords, other than length, really cut the mustard, right? I guess Windows runtime is decent in length, but it's not, what's the word? It's not strong enough, right? It's a pure brute force. You got to remember when you're attacking, when it comes to passwords, there's two ways to increase strength. One is to make the password long, and that protects us against pure brute forcing. The other way is to make passwords, what's the word? Complex. That's the word I'm looking for. Make them complex. That makes them difficult to a dictionary. Well, this is basically a dictionary file, and it is looking for people that have not taken the advice of how to make a strong password. So if you put both of those things together, you make them complex and of decent length, you have a decent password. Okay? Okay, people? Let's get it together. I'm Dr. Phil. I'm here to tell you that this is completely ridiculous. You should never be using a password of this caliber. You, as administrators out there, have the onus to be smarter than that. Okay? And now I'm Mr. Mackey. So do that. These are horrible passwords, but apparently they are working. So good for them. All right. So there's how the scanning works. And then once we get into if brute forces its way through, it finally gains access to that phpMyAdmin system. It drops an IRC bot, which reaches back out to an IRC channel, and that's where it does its command and control, right? And there's a couple of nice IOCs here. We have these files. One's called FB5, the other's called AB5, and they are IRC bots, and they have been compiled for both 64 and ARM. So x64 and ARM architectures. So if it finds itself on one or the other, which are probably the more common ones nowadays, we won't see as many x86s running around out there, but hey, what are you going to do? So here is the actual piece of equipment that makes it all run. You can see it is running. So it says /.xfb5. That is the file name for the x80 or x64 architecture. Then it's just a big one-liner. So it's got a semicolon. It's chmodding, adding the executable bits. So it makes it executable for the FB5 binary. And then it / runs the FB5 binary. Bada bing, right? Go down a little farther. We see the same thing for ARM. And it's AB5 in that instance. You lather, rinse, repeat, exactly what we just saw, and you're off to the races. So once it deploys this IRC bot, right, then it starts communication with the command and control channel and the victim server. So getting them to talk via IRC, and they've got a nice screenshot of this happening. If you've never used IRC before, I highly recommend you start looking into that. It is not as common as it used to be, but it is a still common vector for command and control. Or C2 traffic. So you can see it's giving commands like nick and user and ping and pong, kind of making sure, hey, I'm letting you know I'm alive. Here's what I'm pinging you with. I'm receiving the pong back, and it's changing modes, and it's joining a channel. Okay. So the nick is just what is its nickname that's using in the IRC channel. IRC bots are basically just automated users that get triggered to do X, Y, or Z things when conditions happen. So if you've ever like haunted around IRC channels, you know probably a little bit about that, seen that before. They're very, very helpful in that. But you can build an IRC bot that will respond and do things for C2 communications. So people like to use that. I say people, I mean horrible people that we do not condone. Stop it. No. All right. What else does it do? So it registers itself, inside a cron job. So it makes a cron job establishing a bit of persistence. So it always wants to make sure that that IRC bot is running. So we just do a little bit of cron, right? So cron tab-l grep, then it gives to make sure, hey, am I running? If not, make sure that it does. Bada bing, bada boom. You've got cron going on, keeping you alive at 5, rocking and rolling. That's what they want. Okay. Okay, that's all we have for that. Coming up, almost time for, hopefully we're going to get this completed. Yeah, we're getting close. So let's talk about the MySQL and Postgres services. Of course, it starts checking whether or not ports 3306 and 5432 are open, respectively, for MySQL or Postgres. And then it actually checks to make sure that that is the service that is run. At least that's what I'm gathering. It looks like it's saying this. So it says there is a post on the Golang issue forum because it says that it tries to ping the host database with a certain username and password to what seems from this post. Let's bring that open. It's telling us, hey, I can verify whether or not this is actually on because certain things respond in a certain way. So this was like an issue. And it says database /SQL db.ping context takes longer to time out on certain databases, on certain database host IPs than others, Postgres and MySQL specifically. So if you're running Postgres or MySQL, it will take longer. If you do this db.ping context, it will take longer to time out for the ping than other hosts, other services. Right? And they're asking, okay, what are you running? And then we can see right here the code that they're using to do the ping. And you can see for MySQL, and then here's one for Postgres. And we can see, there we go, right around this region here. We can see for MySQL, root at TCP, bada bing, it's running it. And if it's Postgres, it's using user equals A, password equals B, and DB name equals C. So there you go. So if that stuff works, and you'll notice it said, oh, what did you expect to see? Well, I expected to see a timeout of 2 or less seconds on both of these things. What did we see instead? Well, they said they saw a timeout of 2+ minutes for one of them that was running one of those specific services, and an immediate timeout for one that was not. So I'm able to deduce, based off of that output, whether or not I'm running Postgres or MySQL or something else. And since I'm looking for Postgres and MySQL, I want to see those timeouts. But as we say, we got after that, the malware calls the post result module. And in that we have a web shell that gets dropped. And I'm guessing that some of us out there in that security world, whether it be bad or good, for goodness sake, we have similar mindsets because I have a web shell, and for random ease of use, I called it X. It's a PHP web shell. I called it x.php. Guess what? They are calling their web shell X. That is the name of this lovely thing, right? And we can see that there's this thing trying to do the post module web shell connection, reaching to, this is port 3306, timeout equals 5 seconds, blah, 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 blah. Right, there's the timeout happening. And yes, there's 5432. And then it's moving on to that. Did I move ahead of myself? I did. It's the post result module. We'll get more to that. I just thought that was funny. Let's look at the FTP service, and then we'll take a look at that post result module and get down with that. I'm jumping through my notes here. I'm just so excited about this stuff. All right, so what do we do for FTP? For FTP, it checks for port 21 to be open. Obviously, that's the standard port for FTP. And then it uses the GoFTP module straight from Git, right? Straight up to try to log in. So it's just kind of pulling it from Git in the Go code itself. And we see that here, right? User, bam, that's a very standard way in which to log in. And it uses the APAS SPG proc PGT. But there's the Go FTP library. Let's right click on that and send that to a new tab. And let's take a look at this lovely action. Here it is. And this is just the module. So if you wanted to script up some FTP client for in Go, there you go. Plenty of documentation here, how to work it. There's installing it. So jlaffe, /FTP, jlaffe /FTP. Here's some examples of how you can do this. We can see there's a login, right? Do something with FTP con, store a file, read a file, and all the code that makes all that work. So they're just pulling from this and calling it a day. So let's go back and close this. And you can see, oh, look, GitHub, com, jlaffe, FTP, PTR, server con, CMD, right? That's it. And then we can see it passing the password. So we saw it here trying to pass the username and then passing the password right here. Upon successful authentication to the victim, the malware calls the post result module. Finally, we are at the post result module because this is my favorite part of it because of, well, at least the similarity between my own thought process and these people's thought process. I just thought it was intriguing that we both name our web shells X. So they're calling theirs X. As they said, it does. Here, you don't see that. You can see the IP that it is reaching out to, though. So that's an interesting thing. I'm going to write those down. And you see pst.php /I, a query, which is we observed a hard-coded link query shown as figure 14, which is what we're looking at here. But you can see right here on further investigation of the directories within victim IP address, we found a web shell named X. So it will be the victim IP /X. And there's the SHA-256 for that. And that web shell seems similar to the pst.php file. There's the stuff for that associated with this IP. So there, I guess they're saying what we're seeing is it was called what we've seen in the past with a victim that we've worked with, someone that was compromised by this GoBruteforcer malware. They saw this as pst.php, and now we're seeing it as just X. That's what they found in their next-gen firewall. That's what I'm getting from this. I could be wrong on that, but either way, add both of those things to your IOC list. Says the PHP web shell has reverse and bind shell capabilities. There you go. Bam. You can just click bind. So you give it the server address and the default port. It's a bind shell. You hit run. Bam. You got a bind shell. If you want a reverse shell, you do the same thing. Just hit reverse. It's now a reverse shell. Where do you want it to go? Who do you want to connect to? What port do you want to connect on? And go. We love all these shells as, pen testers and stuff, but we hate them if we have malware installed that is now making my IoT devices and my systems a part of their horrible, horrible botnet, which they sell to the highest bidder to do horrible and nasty things. Anyway, it just gets on me, man. It just grates me. I'm sorry, it's like, why are we? I know, money, right? Money. It's all about the do-re-mi. All right, there's also a packet crafter that is installed in the web shell, or a simple packet crafter, allowing them to basically, if you're not familiar with packet crafting is, this is the protocol I want to use, is the flags for the protocol, so basically kind of manipulating that protocol. Here's the port I wish to use that protocol over, so it's going to be TCP. If it is, am I going to send a SYN flag? Am I going to send a urge flag? Am I going to send a push flag? What kind of flag am I going to set for this thing? And based off the flags you set, you will get different responses. It's a great way to kind of map out networks, especially ones that are segregated and have firewalls and ACLs in place. So sometimes you can use things like ACK flags to finagle your way around firewalling. So yeah, there you go. So you got a little simple packet crafter. Now they can do a little bit of maybe pivoting inside of that network, some lateral movements, our favorite buzzwords. All right, it's making advances. During our hunt for sample Bruteforcer, we found another sample. This is possibly an older version, so there might be, again, this is a multi-stage thing, just like any developer does when they're letting out a product. They test, they build, they test, they build, and finally they have a minimum viable product that is workable, that's usable, and then that goes to market and it gets sold. Same thing is going to happen here, where it looks to still be a bit in the testing phase. Maybe this is the final version, or at least the minimum viable product. Could be, Could be. We don't know. Could see another iteration. GoBruteforcer V2 coming to you in a theater to you near you real soon. As we can see, this has not been picked up as of a couple of months ago. I guess it was a few months ago. It's probably picking up now. So if you grab that hash and you throw it, well, let's do that. Where's the hash? There we go. Let's get it. Copy. VirusTotal time. I guarantee that since they've released this, I almost guarantee a virus. VirusTotal.com. Come on, show me your leadership skills. We are looking for search. Just go search. Bing, throw that hash in there. The old paste-a-roo. Hit it. Yep. Going. There it goes. Churning and burning. Whirring and grinding. Whoa, yeah, so cool, right? Now we have 33 vendors finding this. And let's just make sure they're like vendors that, so like F-Secure, Kaspersky, Microsoft, Panda, Google, Fortinet. Bullet dodged. So if you have a system nowadays, it is definitely keying on this. But that's not too long ago. This sample was uploaded some months ago and has 0 detections. But now, obviously, it has detections. But as it mutates and changes, that changes, right? So you have to keep on top of these things. All right, it has a conclusion. Basically, what can we do about this? Like, how can we spare ourselves? Well, obviously, we have things like IOCs, indicators of compromise. We want to make sure that our antivirus, our firewalls, our next-gen firewalls, our IDSs, our IPSs are all up to date. I have an eyelash in my eye, and it is bothering me. They're all up to date. That's going to be one of your best things you can do. But also, think about how this thing is getting in. Bad passwords. Okay? I will say it again just to make sure we all get it. Bad passwords. Make sure you are using passwords of sufficient length and complexity so that this is not an issue. Again, here are your IOCs. Having a good time. Go through those. Make sure there's the URL and IP that you need to look out for. Looks like fee.warmachine.su, and then it's 5.253.84.159/X. You don't want to see that, because that would be a bad day at the beach. All right, ladies and gentlemen, that is GoBruteforcer. We learned a little bit today about packers and bad passwords, and yeah, and what can happen if you don't have those things on lockdown. So do me a favor. Take a minute, check your passwords, make sure, don't rest on no one's ever going to hit this. Oh, that's good enough. It's never good enough. Is it inconvenient? Yes. But what's more inconvenient, right? Having to clean up a botnet malware and go through, BCDR, but IR. Do you want to go through an instant response, disaster recovery? Or do you want to just move on with your life because you had a good password and every now and then have to be uncomfortable typing in, a 20-character password? It's that simple, ladies and gentlemen. That's all we got to do. That takes us to the end of our episode today. Thank you for joining me, everyone. Again, if you like what you saw, like and subscribe, do all that good stuff. And definitely join me next time. Oh, leave me a comment. I always love you guys' comments. Give me some comments down there. Tell me what you think about this thing. Tell me about other great threats that are out there, or bad threats, I guess is a better way of putting it, that we could learn about and learn from. And so we can make some cool CTI, make ourselves better cybersecurity professionals. Until next time, I give you a fun adieu and be safe.